My name is Henry Zhang, and today I'm going to tell you the quick introduction of our project called the cloud. The cloud means a cloud powered by a crowd. So it is a word mixed up of two words, the cloud and the crowd. Every year, a lot of manufacturers announce and release their new products and devices. And due to its relatively short refreshing period, generally 1 year, many people frequently buy new ones and throw away their old, outdated devices. But still, they're functional and they're capable of doing something meaningful. So our first idea was, what if we can reuse the hardware resources of those machines through the cloud, especially the computing power of the CPUs. But we did some researches and found out it is too hard for us to implement this system, and the network speed is not enough to carry this faster speed of powerful CPUs. So we slightly changed the idea to the storage system. We call it a cooperative cloud storage. So a cloud powered by a crowd. So anyone can share their remaining storage with others. But you will ask, who wants to share their free space? Unlike the traditional cloud services like iCloud or Google Drive, you can get a reward from our service by sharing your free space. At first, we wanted to implement this system through the mobile application, unlike iOS or Android. But to store and retrieve the data from the smartphone, our app should be always running in background for 24 hours a day. But there is a limitation that the current mobile operating systems don't allow us to run an application like for all days. So we pivoted to the desktop application and for sharing free space. So actually, we're developing two kinds of applications. One, the cloud mobile for clouders, and the cloud desktop for cloudies. The clouders is the users who share their free space, and cloudies consume them. We use the same programming language, TypeScript, for faster and efficient development. Now, let me tell you how the cloud works very briefly. When a cloudie tries to upload a file, we split the file into multiple pieces for faster transmission, and we encrypt each piece to protect them from being stolen by the hackers while on the network. And then in the server side, we got some help from Tony and found the algorithm called the Reed-Solomon error correction. For example, there are file pieces like this, and some of them are lost or some broken with some reasons. I love you, Eric. But by using the RS algorithm, we can regenerate the original file from the remainders. we use Go language for this part. It is very fast, and it is really good at parallel processing. Also, we use the Node.js for general purpose APIs like the authentication system. Until now, we've done some works like authentication using Google OAuth, ping-pong connections, and the UI design. Now let's talk more about this ping-pong connection. It is one of the most important part of our project. So what the hell is the ping-pong connection? Now the user's computer is part of our system, and we have to monitor and manage them every second. Like deciding which part is the best for storing the data by comparing the network speed or free space of their hard drives. Also, we have to check the connectivity and have to regenerate the file whenever they became unavailable. We use the WebSocket for this part. It is different from the HTTP protocol. This protocol, the server can be a subject who triggers some actions to the client directly. So we can make a real-time, consistent, and interactive cloud network by using the WebSocket. To maximize the parallelism of the Go language, we created a connection pool which stores all of the available clouders and do some ping-pong connections at the same time for all of them. And thanks to that parallelism of the Go language, we can do jobs of its connection pool itself at the same time with the ping-pong connections. So these are all the contents for today, and thank you very much.